In 1936, a British government committee stamped a research report not for publication. The committee had spent 18 years studying a farming technique that required no chemicals, no machinery, no recurring costs. A technique that multiple independent researchers across France, Germany, and Scandinavia had documented producing harvest increases of 30 to 40%. The same year those reports were sealed, the synthetic fertilizer industry was becoming a $200 billion business. What was in those reports has never been officially released, but the research didn't disappear. It survived in agricultural libraries, in the notes of independent scientists, and in the farming traditions of communities that never stopped using it. It is called electroculture, and the only thing you need to try it yourself costs $3. What is electroculture? Electroculture is the practice of using atmospheric electricity and electromagnetic fields to stimulate plant growth. The concept sounds modern. It is not. The first documented experiments date to 1783, when a French physicist named Pierre Bertholon published a book called De l'électricité des végétaux. He observed that plants exposed to atmospheric electrical charge grew faster, produced more, and showed greater resistance to disease. He wasn't guessing. He built what he called an electrovegetometer, a device that collected atmospheric electricity and directed it into the soil around his plants. The results were significant enough that he published an entire book on the subject. That book was published 244 years ago, and almost no one in modern agriculture has heard of it. The 150-year research trail. Bertholon was not alone. Over the following 150 years, researchers across Europe independently documented the same effects. In 1841, a British inventor named Alfred Bain filed patent number 8783, an earth battery system that used buried copper and zinc plates to generate a continuous low-level electrical current through soil. In the 1880s and 1890s, a wave of European researchers ran controlled agricultural experiments. The findings were consistent. Electrical stimulation of soil increased germination rates. It accelerated root development. It increased yield. In 1918, the British Ministry of Agriculture formed the Electroculture Committee. This was not a fringe organization. It included some of the most respected agricultural scientists in the country. It had government backing, it had funding, and it spent 18 years conducting systematic research across multiple growing seasons, multiple crops, multiple locations. Their findings confirmed what independent researchers had been documenting for over a century. Plants grown in electrically stimulated soil produced more, consistently, measurably, reproducibly. In 1936, after 18 years of research, the committee's final reports were classified, not published, not peer-reviewed, not shared with farmers, classified. Justin Christofleau and the copper coil. The most practical documentation of electroculture came from a French agriculturalist named Justin Christofleau. In 1925, Christofleau published a manual called simply Electroculture. It was not a theoretical paper, it was a practical guide for farmers. Christofleau had spent years testing a specific design, a copper wire coil inserted into the soil at an angle, acting as an antenna to collect atmospheric electricity and directed downward into the root zone of plants. His documented yield increases ranged from 30 to 40% across multiple crop types. He tested it on wheat, on vegetables, on fruit trees. His explanation was straightforward. The atmosphere carries a continuous electrical charge. Plants evolved over millions of years in the presence of this charge. Modern farming, with its metal machinery, synthetic chemicals, and soil compaction, disrupts the natural electrical environment that plants evolved to thrive in. The copper coil restores it. The design Christofleau documented in 1925 is in the public domain. Anyone can build it. The materials cost approximately $3. The China Trial. The most recent large-scale validation of electroculture did not come from Europe or North America. It came from China. The Chinese Academy of Agricultural Sciences conducted field trials of electroculture across 3,600 hectares of farmland. 3,600 hectares is not a small experiment. It is a serious, large-scale agricultural trial. The results confirmed a 30% increase in yield. The trial was documented. The results were published in Chinese agricultural research literature, and they were almost entirely ignored by Western agricultural science. Why you have never heard of this? The answer is not complicated. In 1909, Fritz Haber and Carl Bosch developed industrial nitrogen synthesis, the chemical process that made synthetic fertilizer possible at scale. By 1936, the same year the British Electroculture Committee sealed its reports, synthetic fertilizer was becoming the foundation of modern industrial agriculture. The economics of synthetic fertilizer are simple. A farmer buys it, uses it, buys more. Every growing season, every year, for the rest of their farming life. The economics of electroculture are different. A farmer installs a copper coil. It works from soil chemistry and atmospheric electricity. It costs nothing to operate. It requires no repeat purchase. There is no business model in electroculture. There is no subscription. There is no product to sell at scale. A farming technique that increases yield by 30% with a one-time $3 investment is not a problem for farmers. It is a problem for a $200 billion industry that depends on farmers buying chemicals every single season. The research was real. The results were documented. The reports were sealed in the same decade that synthetic fertilizer became an industry. That is not a coincidence. It is a business decision. The science behind why it works. Modern plant biology is beginning to provide the explanation that Christofleau and the British Committee could only observe. Plants are not electrically passive organisms. A 2019 paper published in Nature Plants documented bioelectrical signaling in plants, the discovery that plants use electrical signals to coordinate responses to their environment, communicate between cells, and regulate growth. Plants evolved on a planet with a continuous atmospheric electrical field. The Earth carries a negative charge. The atmosphere carries a positive charge. Between them exists a global electrical circuit that has been present for the entire history of life on this planet. Root systems in natural soil act as conductors within this field. They draw charge downward through the plant. This electrical gradient influences nutrient uptake, cellular division, and the efficiency of photosynthesis. Modern industrial farming disrupts this system. Compacted soil, chemical treatments, metal machinery that short-circuits natural charge distribution. The copper coil that Christofleau designed in 1925 does something simple. It acts as an antenna. It collects the atmospheric charge that exists above every field on the planet, for free, continuously, without any input, and directs it into the root zone. The plants respond the way they evolved to respond, with increased growth. How to test it yourself. The design is in the public domain. It has been for 100 years. You need copper wire, not aluminum, not steel. Copper specifically, because copper conducts both electricity and the subtle electromagnetic frequencies that Christofleau documented. The basic design: a length of copper wire wound into a coil, inserted into the soil at an angle facing north. The angle matters. Christofleau documented that alignment with the Earth's magnetic field amplified the effect. The coil collects atmospheric charge. The wire conducts it downward. The soil distributes it through the root zone. Installation takes minutes. The cost is approximately $3 for enough copper wire to treat a standard garden bed. The patents on Christofleau's original design expired long ago. The research is in public domain agricultural libraries. The Chinese trial results exist in published literature. Everything needed to test this yourself has been available for 100 years. The only thing that was missing was someone to connect the dots.